With the recent advances in crowdsourced data, it is now possible to forecast the impacts of traffic congestion more accurately than ever before. This week on LokadTV, we're delighted to be joined by Cédric Hervet, who's going to discuss with us how the increases in quantum computing and the ability to route optimize in real time has led to delivery companies changing the way they actually operate. So Cédric, many thanks for joining us today.
Thank you for welcoming.
Perhaps as a sort of a starter, you could just sort of tell us a little bit about what you do and also about Cardinal, the company you work at.
Okay, so Kardinal is a company that specializes in route optimization in real time with a great deal of context awareness in the way we proceed. Usually, tours are optimized by humans manually, so they will, plan, schedule the thing they have to do for their drivers, for their technicians, in a manual way. This is clearly suboptimal, but in another way, humans have a great capacity to handle emergencies, events, problems, and they have a great capacity to, envision the global scope of their priorities to somehow manage to make a decision. And algorithms are poorly equipped for that, especially tour optimization algorithms. On the contrary, there are softwares on the market that are already providing route optimization, but they do it in a very static way. That means they get data, stuff to do, people available, they will mix it somehow and provide an optimized solution for the route schedules. And this is problematic because the first event that you will encounter will somehow destroy the quality of your tours. And once trucks are departed on the road, there are other issues, like you just said, traffic congestion, customers that are late, that are absent, that want to reschedule their appointment. All these kind of events can somehow destroy the performance of what you're doing. So at Cardinal, we believe that the right way to optimize your tours is really to never stop optimizing them. And this way you get a greater capacity to really handle problems as they go. Another key aspect of what we're doing is that we have a strong focus on really not removing the human from the equation because in many ways humans are they know stuff. They know their job and they know stuff that can't be found nor modeled in any database. And this is really important not to remove them from the whole process because they have somehow a strategic vision of over their activity.
Yeah, this idea of using a human brain and making the most of that, particularly in those emergency sort of scenarios, is a really interesting one. And I think it's something you'd probably agree with as well, Johannes, making the best use of the human brain in terms of being an addition to an optimization and making the best use of it.
Yeah, absolutely. I mean, that's the idea of making the most of smart people that are very aware of the problem that the company is trying to address with its own supply chain, using the best of what modern computing power has to offer. It's pretty much, I would say, at a very high level also the strategy of Lokad.
Okay, great. And today we're talking a bit about real-time route optimization. Why is that of interest to you from probably a supply chain perspective?
I mean, obviously, Lokad, when we think about supply chain optimization, we don't exactly think at the same time scale. I mean, if I compare a bit what Cardinal and Lokad, who are both enterprise software vendors, are doing, Cardinal is doing route optimization, so decisions that can be re-challenged every minute or so. I mean, it's real time. It's not exactly like microseconds. You're not piloting real-time robots that are doing picking in a warehouse. So it needs to be like swift, but it's not exactly like the microsecond either. And Lokad, on the contrary, it's more like the decision that you want to take for tomorrow or up to, let's say, 1 year ahead. So that's I would say the time range. So obviously, the fact that Lokad can optimize the supply chain, we are typically making assumption on what can be made about delivery when we say we want to do inventory rebalancing between locations. It can be stores or warehouses. Obviously, we heavily depend on the fact that there is tons of agility from tools that can be provided, such as route optimization, such as provided by Cardinal. And the way at Lokad we see it is that the more agility you have with your routes, so for example, you can rebalance stock between stores easier, it means that it lowers the cost that we see to do those optimization. Thus, we can do more of them.
Okay, let's move on with that idea of agility then. I mean, it wasn't so long ago that I'd be printing out directions on Google Maps and I wouldn't be very able to sort of make a change from my route if there was traffic up ahead. Nowadays, we're much more sort of reliant on things like cell phones and GPS systems. So how's route optimization sort of developed over the last few years?
Well, route optimization, there are two problems that you are mentioning here. There's the problem from going from one point to another and finding the right road, and this is especially for that use case that stuffs like Google Maps are built, and there are the more general problem of having end stops to visit, and you want to also know in what orders you will visit all these stops, knowing many things about the traffic and everything. And so we are really focused on the second problem, which is much more difficult, because if you have just maybe 20 stops to visit, the number of combination is so high that it would take you, even for a very powerful computer, thousands of years to compute all the possible combinations. So obviously you need algorithms that are much smarter than just enumerating everything, and that's where the math comes in. But beyond that, this capacity from mathematics to model that problem and trying to provide algorithms to solve it efficiently, it has been developed for many years now. I think it started in the 60s, but the actual implementation of such algorithms is very relying on data, on the availability of the data, traffic data especially, because you can build very optimized routes. If the data you gave the algorithm is wrong or inaccurate, you will just provide infeasible routes. And okay, you would be happy with great KPIs. You've got, I don't know, maybe 10 to 20% drivers less, less kilometers traveled and everything. But if it's infeasible in practice, it doesn't make really sense. So what we're going to do at Kardinal is really focusing on providing routes that are feasible. Giving them to a driver is telling, okay, I probably would not have to do it this way, but it's obviously smart, and I think I can manage to do it in my day without, finishing 2 hours later, which is actually their daily life today. They are always working extra hours. So yeah, what we're focusing on right now is taking all these theoretical mathematics, beautiful theorems, beautiful math really, and beautiful algorithms to make things realistic, feasible in practice. This is really how we see our work at Kardinal.
Yeah, and we'll get onto the idea of sort of availability of data in a little bit. But in terms of, from what you've observed, who are the key sort of companies and the key players that have really driven this growth and driven this expertise in route optimization?
Where I see is that first there has been like intense development for online solutions for pretty much everything. For example, I think historically probably the one company that literally did something near magical in this area was Google. Search engines before Google was literally something people didn't realize at the time, is that the companies like Yahoo and Alta Vista, they were actually updating their index something like once per quarter, for the web pages. So literally you were getting search results that were always out of date. So if you had a page that only appeared yesterday, it would never show up on the results. And Google was very innovative on many fronts, many fronts. But one of them was to really have things that were completely online. So you want to have like the best results for your query, but the reality is that with new pages being added to the index like all the time, and actually they didn't quite manage to have it all the time. I think at the beginning they were only doing like weekly refresh, but it was like already like 20 times faster nearly than most of the competition. But you see, that was a transition toward a problem where you fundamentally wanted to have like an always up-to-date results under changing conditions. And here I don't think that Cardinal or Lokad, you pretty much use the Google algorithm that were pretty much designed for search engine extra, but it was more like I would say a source of inspiration of the sort of stuff that you can do at scale, with the proof that it can actually work. And it's very interesting. So for me, that was, and many other players started to do similar things on many different type of problems. And I think there was a new wave of people who had like, how can you have the online version of a problem that is much smarter, and also something that is probably very different from what Kardinal is doing right now compared to what people were doing in the 50s, is all those constraints, all those non-linearities where you want to have something that is an optimization that can deal with a lot of stuff that are mathematically hard to represent. You know, non-linear constraints, the fact that maybe your driver cannot drive more than X hour because there is like an employment regulation that says this and this and this and this.
Okay, let's talk a bit about the data then. I mean, what's the data that's actually of interest to Cardinal, and where do you get that data from as well?
Well, there are two main sources of data. The first source is obviously our client. He's providing us with the orders we have to optimize. He's giving us the most accurate description possible of his activity, and that can be, just like you said, you know, constraints over their legal constraint for working hours of their drivers, drivers availability, where do they start, where do they take the service, what kind of vehicle they are driving, what kind of capacity, is he, you know, cemented to somehow transport dangerous goods, is it possible for him to, you know, conduct that specific technical intervention that requires a specific skill set? All this kind of data is somehow defining constraints over the activity, and so we need to understand this. There are also data coming from the client describing the orders themselves. So that could be packages to delivers. That can also be some interventions, like for example repairing IT equipment. So all these are interventions, and so this is really describing the activity. And on our side, we are relying on technological partners like Here Technology, which is our partner for, you know, getting the distance data. We need to understand how long it takes to go from one stop to another, and we need to understand how the traffic will change over time. We need to also, once trucks are on the road, to get the actual real-time traffic to adapt our tools. So Here for us is a data provider that is giving us this data and we are handling this data with our algorithms to really provide updated solutions. So those are the two main sources of information for us.
Yeah, and you talked about this kind of online solution, this rise and growth of online solutions. I mean, from a technical perspective, what sort of challenges does that introduce, being able to work in real time?
I mean, obviously, real time introduces massive amount of complications. I mean, first, there is no such thing as real time. You know, the speed of light is finite. You would say, oh, it's incredibly fast. And we say, yes, but when you think about it, it's not that fast. The problem is that once you have distributed computer systems and you need to go back and forth from multiple data centers and you do thousands of kilometers every single time, you would say, oh, it's just milliseconds. Yes, but if you need to do thousands of round trips, then you start to realize that it takes seconds, you know, to get results. So actually achieving, you know, real-time systems when you operate globally, it takes a lot of skills. Plus, there is so many things that can prevent, you know, having a good real-time system. You would think, oh, my system on average is super fast. Is yes, but think of your computer. You know, how many times do you try to do something with your computer and for like 2 minutes it's kind of stuck because maybe there is like a Windows update going on or whatever. So the reality is that our computers are on average very fast, yes, but if you start thinking about the worst case is they can be actually pretty slow. And again, once you have like an enterprise system, you want to think that typically the speed of your system is going to be whatever is the slowest that you have, which, by the way, if you have like many machines, the slowest can be very, very slow, because if you have like many machines, one of them for some bizarre reason, an update of some kind or whatever, it's going to be very slow. So real time is in itself a set of challenges which are very complicated. Another part of complication is that suddenly you introduce dependency to partners, which means that how can you, as an enterprise software vendor, make your service very available and reliable, even if your partners are not. Again, The problem is that the more dependency you have, the more potential problem for downtimes. If you are in terms of uptimes, your service, if your service is only as good as your dependencies, your third party technological providers, then it means that every time you move down the chain, you get something with lower availability, lower uptime, and lower and everything. And so that is also quite a challenge.
Okay, and we're now sort of entering a sort of an era where actually the end user can have control over that data. So for example, with Waze, you can now say if there's a police moving speed camera somewhere. Do you think that's a positive impact, the fact that we can now control these pieces of data?
I mean, it's obviously something very important to have that capacity, especially in context that I was describing before. We at Cardinal we are paying very much attention on keeping humans on board the system, because once they lose control over it and everything is automated and they can't really check that the algorithm is doing something relevant to them, and especially once they don't. I mean, they lose so much understanding of what is happening that they can't really provide their expertise, and they always have an expertise. I mean, I have this short story of when we started to do what we are doing. We were, trying to challenge the tools of drivers, and we were proposing our own optimized tools, and they always had an example of something that the algorithm could not see. And a funny example is that, okay, we had this very beautifully optimized route. It was obviously the perfect way of, visiting all those stops. And when the driver saw this, he was not focusing on the general aspect of the tools, which was kind of better of what he would have done anyway, but he was really focusing on some specific stops. He was telling us, okay, so you're telling me that I will deliver this person here. It will be 4:45 p.m., okay? And here there is a school, and I know that every parent will be parking in that street, and I won't be able to park myself to just make that delivery. So, okay, this is obviously mathematically optimal, but I know that this is delivery at this specific time. I mean, it's just 15 minutes, but it's impossible to deliver someone in this 15 minutes. And this is really something, I mean, for those working in data, the cost of knowing that in advance to avoid that specific stop at 15 minutes in advance, anticipating that fact is very costly for us. And I mean, it's pointless because we have someone in the truck knowing that. So the key interaction we are trying to implement with them is, okay, stuff that we will never know, and we won't never really try to know that because it comes at a too great cost for us. So just give us that input. Okay, you can challenge the algorithms even when you're on the road, and what we're trying to do is that many events can happen. It can be problems from the clients, from the data, anything, but we also consider that the user's input is an event for us as well. And if he thinks that something is really better, he can choose to do otherwise than what we just suggested. And what we will do is just, okay, you take that decision, this is the impact. We just re-optimize things, this is the impact, and then you can make an informed decision. And you're really the master of your tool, because you probably know stuff that we don't know. So to really answer your question, it's really important that data and control over the data, because data itself, it's just, I mean, if you can't understand it and if you don't have something telling you what this data actually mean, it's pointless to anyone. But once you're capable of, giving insights on what the data means, on what the decisions you are providing, humans are not removed; they are augmented somehow. They take better decisions because they have information of the impact of our computations, and with the other things you have in mind, you can make the best decision possible. This is really what we are trying to achieve, the right combination between the two.
Yeah, and another sort of example that I sort of came across when I was doing a bit of research for this was in the US, there was all the wildfires, and when people were putting in their routes to try and escape these wildfires, obviously the roads where there were fires, Waze was showing them as clear, and they were actually directing them through that way. Yeah. So having a way of sort of adjusting that end data is certainly interesting.
Yeah, definitely, because stuff that are out of the context that the algorithm actually handles. So you need to really take that into account when you're doing what we're doing.
Yeah. And would you say from a data perspective, we're a bit too reliant on some of the large companies, so sort of the Amazons, the Googles, the Microsofts, they very much kind of dominate nowadays. Would you say we're a little bit too reliant on some of those big companies?
I would say probably yes, but also the fact that technology is really fast moving. So if you look at map data, there is not that many providers, worldwide. There is even the question is whether map data should be a common good. And by the way, there are some people who are trying to do that with open maps and whatnot. But the reality is that when you have technologies that is super fast moving, it's hard for many companies to compete. Usually when people say winners takes all, what they forget in technology is that frequently things rotate swiftly. So yes, but it's not the same winner at the same time. So right now for maps, indeed, there is not that many players in the market. It's fairly concentrated, but I see also plenty of changes where data that was considered as very hard to access data is now getting closer to be more like a common goods with open maps and whatnot. It will take a long time, but what I suspect is that by the time those things becomes really like commodities. The problem is that the problem will have moved to something else entirely, so that yes, you will still have like private companies that dominates, but they will not be necessarily as strong as they used to be, etc., etc. So bottom line is probably right now is as long as there is some healthy competition. I believe that there is some competition. I mean, maybe Cardinal, you're on the front line on this area, but I would say for map data, there is probably like 4 or 5 players that qualifies. But indeed, it's still a fairly concentrated market.
Yeah, definitely.
Okay. If we start sort of wrapping things up today, as a sort of a final point, at Cardinal, you're very sort of involved in research and development. You've really benefited from some of the advances in kind of AI in recent times. What's the real things from a research and development things that excite you over the next sort of couple of years?
Yeah, well, first there's what we're doing at Cardinal that excites me a lot. We have PhD students, working on these aspects of, solving the online version of optimization, and they are really expanding the scope of operations research as a mathematical field to new extents to really handle our problems in the proper way. But we've also seen other things happening in the AI community as a whole. There's been stuff on reinforcement learning, which is really a different approach of what we are doing with operations research. Is somehow teaching algorithms to kind of know what the best decision is without telling him explicitly what possible decision, what the right decision is, which is very different philosophically from what we are doing at Cardinal, where we are telling the algorithm what is the global scope of possible solutions to a problem, and telling him what is a better solution than another, so he can really focus on finding that solution inside a closed envelope of possible solutions. Reinforcement learning provides another way of doing it, and probably very suited for real-time decision making. I think the limitation today of this approach is that it cannot really handle the variety of constraints we handle with our techniques, but who knows, we've been very much surprised with what reinforcement learning could do at playing Go, for example, or even video games now. They can beat very strong players. So this is really something we are following. And I mean, it's really prospective, but we've seen recently Google announcing that they somehow reached the quantum supremacy. That means having quantum computers solving problems in short times that are unavailable for normal computers if they had to enumerate all the solutions. And we know that there are quantum algorithms that are suited for solving the traveling salesman problem, for example, which is one of our core problems, and they can solve in seconds optimally problems that would take thousands of years to solve for a computer that will just enumerate. So this is also something we need to follow. Obviously, this is very very long term, and with our algorithms, we are by being smart in their conception, we can already match the speed of quantum algorithms. But quantum computing somehow yields at its core a kind of democratization of making all these problems that are hard by nature to make them easy to solve, and this is quite something interesting for us, because obviously if our problems become easy to solve tomorrow, we will have to be on the front of handling this technology to really help our clients perform much better than today.
Okay, brilliant. Well, thanks both for your time today anyway. It's really interesting.
Thank you very much.
So that's everything for this week. Thanks very much for tuning in, and we'll see you again next time. Bye for now.